Hello, folks. This is going to be a video that probably needs to get paused. It's going to be working through a sheet that may or may not be posted to you about trying to cover kind of all of the basic factoring techniques for factoring polynomials that we'll be needing and responsible for in this course. Most of them you have probably met before. Some of them you were perhaps not really an expert in, such as difference of cubes and sum of cubes hang people up a lot. Factoring quadratics whose leading coefficient is not a 1 hang people up a lot. Grouping hangs people up a lot. Anyway, there's a variety of things to get through, and I'm probably going to have to pause this video and complete it another time. So first thing I want to make sure you know is that the first line of attack is always to try to, what we say, pull out the greatest common factor. That is always what you should try to do first. You cannot always do it, but if you can do it, then you should do it. The first line of attack is always to try to pull out the greatest common factor. So I'm going to write these couple of polynomials here. This one here is 42x to the 4th y to the 5th z minus 18x to the 2 y to the 7 z to the 3. And the second one is negative 12x to the 4 plus 16x to the 3rd minus 8x to the 2. And in both of these are instructions. Our goal, our task, is to factor each of these polynomials by pulling out a greatest common factor. Now, this polynomial here, it has two terms, this one and this one. Notice that each term has 3 variables, x, y, and z, but the polynomial itself only has 2 terms. The common factor out of these 2 terms to pull out consists of figuring out that 42 and 18 have a common factor of 6. So we're ripping out a numerical factor of 6. This guy's got x to the 4, this guy's got x to the 2. The common factor that we can rip out is x to the 2. This guy's got y to the 5, he's got y to the 7. The common factor that we can rip out is the y to the 5. This guy's got just z to the 1, that one's got z to the 3, so what we can rip out from both is z to the 1. What is left behind when we do so is the 7 that is needed to turn the 6 back into 42. We used to have x to the 4, we ripped out x to the 2, that leaves us with x to the 2. We used to have y to the 5, we ripped them all out, so there's no more y's, and we used to have z, we ripped it out, so there's no more z's. And then we've got our minus sign. We used to have an 18, we divided by 6, it left us with 3. We had x to the 2, we ripped them both out, that leaves us with no x's. We had y to the 7, we ripped out y to the 5, that leaves us with 2 copies of y, that being y squared. We had z to the 3, we ripped out 1 copy of z, that leaves us with z to the 2. And this is the intended final answer. The instructions are factor this thing by pulling out the GCF. This is the GCF, but to say to factor the polynomial requires not only that you pull out the GCF, but you also write it down what's left behind, multiplied by the GCF you pulled out. Okay, factoring this one here involves another little technique from a past life, which is that when you pull out a GCF, if the leading coefficient has a negative on it, then you also generally pull out the negative when we encourage you to do so. So the leading coefficient here is negative 12. So for sure, we're going to pull out the negative. Now, the 12 and the 16 and the 8 have a common factor of 4, so we're going to rip out 4, or I suppose a negative 4. We've got an x to the 4, an x to the 3, and an x cubed. So, sorry, an x to the 4, x to the 3, and an x squared. So the greatest common power is the x squared. So what the GCF is actually negative 4x squared. Now, what's left behind is, of course, positive 3x squared, because that makes negative 12x. And then that used to be a positive, but we ripped out a negative, which leaves us with a minus, because it's the negative that brings us back to positive when we distribute, of course. So we're left with minus 4x here, because the negative 4x squared times minus 4x brings us back to plus 16x cubed. And then what's left here is plus 2, because the negative 4 times the positive 2 makes the negative 8, and the x squared doesn't get cracked backwards and tell you a secret that a lot of people don't know. A lot of times students confuse the word factor with the word simplify, or the word solve, or heaven forbid, the word do. I said that the instructions with these words factor these polynomials by pulling out a GCF. I didn't write them. I sure should. The reason I should is because the verb to factor is a really important verb, and you need to know what it means to factor a polynomial. So let me tell you. To factor a polynomial means the following thing. It means to write it as a product of polynomials with smaller degrees. Smaller degrees than the guy that you were trying to factor. Now, when you factor a number, everybody kind of generally knows what it means to factor a number. You try to write the number as a product of two numbers that are smaller than the number in question. Like 20 equals 4 times 5. 4 and 5 are smaller than 20, and everybody knows what that means. Or 20 equals 10 times 2. And 10 and 2 are each smaller than 20, and everybody knows what that means. Maybe we're really hardcore and you write the prime factorization of 20. You say 20 equals 2 times 2 times 5. That's the prime factorization of 20. And so you bring 20 as a product of three things, 2 and 2 and 5, and all of them are smaller than 20. Now, there's a little side problem about 20 equals 20 times 1. That's true. 20 equals 20 times 1, but we kind of consider it not a real good factoring because 20 is not smaller than 20. I mean, this is true, but when you factor something, you're really trying to figure out if there's a way to write it besides calling it itself times 1. Anyway, as far as polynomials go, if I just say you're trying to factor something, meaning that means to write it as a product of stuff that's smaller, you wouldn't necessarily know what it means to say that one polynomial is smaller than another. Does smaller mean like there's fewer terms, like it's shorter as opposed to like a whole bunch of long terms? Or does smaller mean like the coefficients are smaller? Or does it mean that the leading coefficient is smaller, or that the constant is smaller, or what? See, smaller for polynomials could mean, I guess, a lot of different things. So let me be the first to tell you what smaller means for polynomials. It means smaller degree. So when you give a student a polynomial, we say a factor. A lot of times they say, well, do you mean to just solve it? And the answer is, no, I do not mean to solve it. No, I do not mean to simplify it. No, the verb to factor is a really, really, really well-defined verb. And to factor a polynomial means to write it as a product of things with smaller degree. So let's take a second to step back and check that we actually accomplished that with these two. This polynomial here was 4th degree, of course. This term was degree 4, this term was degree 3, this was degree 2, so the whole polynomial was degree 4. And we wrote this degree 4 guy as a degree 2 guy times another degree 2 guy. So we wrote this degree 4 as a degree 2 times a degree 2, and that means we did what the verb factor means, and that's good. For those of us that remember that when there's multiple variables, things get a little more funky. This polynomial here, you'll remember, this term here is degree 10. Because it's degree 4 plus 5 plus 1, that's degree 10. This term here is degree 12, because it's 2 plus 7 plus 3, and that's 12. Of course, altogether, this polynomial is degree 12, because the degree of a polynomial means find the degree of each individual term, and then whatever the largest degree of any of the individual terms is, that's the degree of the polynomial. So there's a degree 10 and degree 12 term. The degree of the polynomial is degree 12. Okay. But notice that what we've done is we've written it as this guy, which is degree 2 plus 5 plus 1, which is degree 8, and we've written that degree 8 guy multiplied by this. Now this here is degree 2, and this term here is degree 2 plus 2, which is 4. So this whole thing here is degree 4. So we've written this degree 12 thing as a degree 8 thing times a degree 4 thing, which means that we have actually factored it in the sense of what the verb to factor means, which means to write the polynomial that's given to you as a product of polynomials whose degrees are smaller. That is so important. Students, a lot of times, again, they say, like, I don't know what factor means, or they say they just use the word factor and simplify and solve and do, and they use them all interchangeably, and they're not the same verb. They're not. Just like running and walking and swimming and jumping, they're not the same action. Neither are the actions of simplify or combine like terms or factor or solve. They're not the same thing for different words. And it's so important that you know what this means. That's the first password of this video set, is to tell me this, to tell me that you know what it means to factor a polynomial. To factor a polynomial means to write it as a product of polynomials with smaller degrees than the one that you're trying to factor. Magic pause. All right, folks, what's on the board now is steps towards leading to the idea of what's called factoring by grouping. Factoring by grouping is a really important technique, and these two problems on the board are not really factoring by grouping because the grouping has already been done for you. But these are two examples that lead you towards seeing how factoring by grouping works once you see how it looks once someone else already did the grouping for you, so to speak. Okay, so the instruction with this one and this one is to sort of factor by pulling out the GCF, but the GCF kind of has a funny flavor now because, see, we're trained to think about pulling out factors that maybe have a numerical coefficient or they maybe have variables to powers, but we usually think of the factors that we pull out as being like monomials, just one term, meaning like 7x squared or negative 2x cubed y squared. Like we think of pulling out one term, even though that term might have a numerical coefficient and variable parts, it's just one term. So this looks kind of funky right away because you see this and this says, all right, so I've got 7x times 3x minus 4 plus 8 times 3x minus 4. Your first temptation and first, inclination is probably to you go, oh, am I supposed to distribute this and combine like terms? Well, that's a good thing to do sometimes, but not if the instruction said to factor by pulling out the GCF. The key here is just to recognize that the GCF is this bundle that's 3x minus 4. But we're not used to thinking of bundles that are multiple terms, like 3x minus 4 in parentheses, as being a factor in its own right. So the first level is to make sure you realize that this is saying, hey, look, 3x minus 4 is what gets pulled out. It's like saying 7x times my hand plus 8 times my hand. What pulls out? My hand. And under my hand is 3x minus 4. And what's left is the 7x plus 8. Now, for reasons that I've never really understood philosophically, students very often with this particular problem, they want to say, hey, shouldn't I pull out 3x minus 4 squared? The answer is absolutely not. No, indeed. And then they say, well, wait a minute, but there's two of them. And then you say, well, not really. There's this one of them, and it's being distributed. There's the one of them times 8, plus the one of them times 7x. There is not two of them there, and there shouldn't be, and there's not. But somehow that very commonly happens, and yet the reason it happens has somehow to do with the fact that the parenthesis mess with people's minds, like I was saying. If I were to hand you this, 7x times a plus 8 times a, Every student that asks, hey, isn't that 3x minus 4 squared? And the answer is no. But like every student that asks that, if you ask them to factor 7x times a plus 8 times a, they would not. But if you ask them to factor that, they would completely just say, look, I'm going to pull out the a, and it's left with 7x plus 8. And they would not be troubled by that, and they would not ask if it was an a squared. And it's not. But something happens in the mind that when the factor you're looking at becomes a longer expression, people tend to violate principles that they otherwise don't violate. Take my word for it. I've been doing this a long time. Anyway, so this is an example of like recognizing a common factor that happens to be a parenthesis that you pull out. But the thing is, you have to resist the temptation to like distribute here, because the instructions are like, no, no, no. We left it for you so you can see this kind of like matching bundle. Okay, you move on to the next one. It says 9w times w plus 3 all cubed plus 5 times w plus 3 all squared. So the common factor involves w plus 3. Like there's 3 copies of it here, and there's 2 copies of it here. So what's the common amount of it you could rip out? 2 of them. So the greatest common factor is to pull out w plus 3 squared. And then what is left behind is the 9w that was there times the 1 more copy of w plus 3 that was there. And then out of here, you pulled out both copies of w plus 3, but you're left with 5. Now, a lot of times textbooks give you this problem and they say, look, we're going to factor out the GCF, and then you write this answer, and then the book goes, well, that's right, but we're not going to accept it because we wanted you to distribute here. And then you're free to get a little mad at that. Be like, well, now, wait a minute now. You didn't say pull out the GCF and then distribute whatever was inside the bucket. You didn't, the instructions didn't say that. And well, sorry, we didn't say that. Anyway, which means that if you enter this in as an answer and the thing doesn't like it, okay, then distribute here and call this 9w squared plus 27w minus 5. And then you got your w plus 3 squared. Now notice I pulled a sneaky move on you. I turned the bracket into a parenthesis. Why? Because the reason I had the bracket was because I had parentheses inside the bracket, and I was trying to keep your eyes seeing, you know, the difference. But then once I blew through the parentheses with distributive law, I felt like using the bracket was cool. Now, you might also be saying that you want to think of this as maybe it feels good to you to pull out the w plus 3 to the right side, which is totally cool too. You can certainly write this as w plus 3 squared on the right, and then this stuff on the left, which would mean this stuff on the left. And those are both completely, totally cool. Now remember, this was all leading towards factoring by grouping, but I don't really think that these should be called factoring by grouping, because whatever grouping is, you didn't have to do it in these problems. I had already done it for you. I did the grouping, and that's what let you see that you had this matching bundle here, or you had this double copy of the matching bundle here. Magic pause. Oh my gosh, I had no idea that I had not hit the magic pause. Whoopsie daisies. Well, sorry for that delayed loading. Oh well. So here is two more factoring by grouping problems. So these are labeled A and C in the section of the sheet in case the sheet exists in your hands, and if it doesn't, whatever, these are two good factoring problems. Except they're not really that good. That's why they're introductory problems. Let me tell you a little secret about them. First of all, when I tell you to factor these two by grouping, I need to give you an extra hint that says, hint, please don't combine the like terms in the middle. Like, you see this one here? 27x squared plus 30 and 60, 27x squared plus 63x plus 12x plus 28. What's your first tendency? You see those two and you're just dying to glue them together and call them 75x. You know you are, because we always tell you to combine like terms. And here's like terms. I got to tell you that to do this problem by grouping, whatever grouping means, don't combine the like terms. I know you want to. I know you want to. Same with this one. I know those two terms in the middle, negative 49w minus 40w. Golly knows you want to combine them. Resist the temptation. These are really very artificial, very first level, very fake grouping problems, where I have to beg you to resist the temptation to combine the terms in the middle so that I can illustrate the grouping technique too. Now, a good grouping problem is one where you don't have the temptation. You don't have to worry about not combining terms in the middle. Let me point out to you that factoring by grouping maybe ought to be called factoring by grouping into pairs. And let me then suggest that whatever it means to factor something into pairs means you must have pairs of it. Now, pair means two things. And if you've got pairs, that seems to mean you've got at least two pairs. It means you've got four things. And that brings me to the most important thing about factoring by grouping. Factoring by grouping is a technique that we often try to use if there are four terms. That is like the trigger of how you know that grouping is probably going to be a strategy that you might want to try. If you're given a polynomial with four terms, four of them, and you're told to factor it, and you don't see anything else right for you to do, I want this to ring in your head and go, oh, right, Professor Durna was yelling about, I know it's grouping when there's four terms, or I know that four terms anyway is when grouping is a good thing to try. And this is so important to know that you got it. That's the second password of the video. I want you to tell me that factoring by grouping is a technique that you try to use if there are four terms. Because if you say that enough, and if you type it to me, and you talk to your friends about it, you'll all remember that, right, when there's four terms, you factor by grouping, or you try to, and that way you don't need me to make my terrible joke I'm about to make. Grouping starts with G, and it rhymes with pooping. Because a lot of times when you give somebody four terms in class and say, how do you factor it? Everybody goes, and they're on their phone or whatever, and you say, hint, it starts with G and rhymes with pooping, and they all go, grouping! Anyway, factoring by grouping is something that you do, or you try anyway to do, when it's four terms, okay? And here's how you do it. You group it into pairs, and you look for a GCF of each pair. It seems weird, because usually we talk to you about, well, look, you look for a GCF for the whole thing, and if it's there, great, and if it's not, whatever. Factoring by grouping involves taking this expression with four terms, looking at the first pair, 27x squared plus 63x, and pulling out a GCF of that pair and only that pair. The GCF of that pair is an alarm that's ringing. The GCF of that pair is to pull out 9x. And you're left with 3x plus 7. Okay, so that's the first thing about grouping. There's four terms, and what you want to do is you want to look at the left two terms And then we want to look at the right two terms. But before we do that, you have to write down the symbol in the middle. If it's a plus, write a plus. And over here, where it's a minus, write the minus. Is really important, because if you don't write the plus or you don't write the minus, and a lot of students don't, trust me, then if you don't write that plus or minus, later on, you're going to forget that there was any symbol there if you didn't write it, and then you're going to start to think it's a multiplication, because that's what happens when you don't write a symbol, is you say, oh, when there's no symbol, it's a multiplication. And that's why I need to beg you with my hands folded that in a case like this, write that middle symbol plus. And in a case like this, please write that middle symbol minus, or on that. Okay, so I write the plus. Now I look back at these two terms, 12x and 28. What GCF can I rip out from them? 4. And it leaves you with 3x plus 7. And now all of a sudden, you know the trick. Now all of a sudden what happens? You smile. Why do you smile? Because you see a matching copy of 3x plus 7. And you say, oh, sweet. I'm going to pull out that 3x plus 7. And it leaves me with this 9x plus 4. See, once you and I ripped out the 9x, ripped out the 4, then it looked like the last couple problems, which I kept saying somebody had grouped for you, But here we did the grouping ourselves, and then we recognized the matching factor. Okay, so we walk over here. I need to, again, ask you, please don't combine these terms in the middle. I know you might want to. Let's instead look at this first pair. 56w squared minus 49w. What can we rip out? 7w, of course. Leaving me with 8w minus 7. Okay. I beg you to write that minus. In fact, I beg you so much, I'm going to make that another password, because it is so essential. If you want to know how to factor polynomials, you've got to know how to factor by grouping. And if you want to know how to factor by grouping, you've got to know how to do what I'm about to ask you to say for the next password, which is simply this. Whatever the symbol is between the middle terms, write it down. If it's a plus, write a plus. If it's a minus, write a minus. I know I sound really mean when I say it. I'm begging you. Write the minus. That again, that's the third password. Whatever the middle symbol is, write it down. If it's a plus, write a plus. If it's a minus, write a minus. Here it's a minus. Okay, write the minus. 40 and 35 have a common factor of 5, right? Okay, so what's left here is 8w, and what's left here is 7. But what symbols here? Now, if you're in a class full of 15, 20 people, lots of them start shouting out plus, and the reason they're shouting out plus is because they see a plus there. Now, the reason I covered this with my hand, in case you're wondering, is because I didn't want you to see that it was 8w minus 7. Because if you see that it's 8w minus 7, you're hopefully going to be thinking, man, I really hope I end up with an 8w minus 7 over here too, because that's the whole goal, is to hope to get the matching parentheses, right? So I wanted to cover this up because I also know that the tendency to see that plus and write a plus here is really strong, and it's also wrong. This is a minus, because this brings you back to minus, and this brings you back to plus. And then you remove your hands and you smile again, because you've got a matching copy of 8w minus 7, but only if you wrote the minus like I begged you. And that helps you discover that that's a minus and not a plus. So the common thing to rip out now is the 8w minus 7. And you're left with 7w minus 5. Now, again, if you're wondering what am I talking about, why do you have to write it down in the middle symbol? A lot of people don't write that, and then they just write a 5. And then they sit here and they see a 7w and a 5, and they didn't write anything. and maybe they inject a plus, which is wrong, that's minus. Or maybe they don't see the symbol because they didn't write one down, and then they haven't really multiplied, and they call this 35W, and the whole thing's shot. It's easy to do the things that you need to do stuff right. One of the things I continually am trying to do in these videos is to beg you to do what's right and to not make the mistakes that I know people make, and it's why I want you to not make them. Much more grouping to come, far more techniques to expand on, but for now I have to stop this video. I'll see you.